Good afternoon, everybody. Thank you for joining us today. As we go through today, if you have any questions, you can send them in using the Q&A interface in Zoom there for you. So again, any questions, don't raise your hand, don't do anything like that. Just send them in with question and answer. Depending on what the question is, I will either answer it as we go or get to it at the end of today's presentation. So today we're providing sort of a top level overview of our wireless product line. We've got a number of different access points, and there's often some confusion, especially when it comes to certain models, since we've got like, I think 5 different AX1800 access points, for instance, trying to understand which access points you need. For the most part today, we're just going to be talking about our business rated access points. So those are our NWA, WAC, and WAX series products that have 3 or 4 digits in their name. So NWA 110AX, WAC 6103. We are going to talk a little bit about the 50 and 90 series, but those are more prosumer oriented, so we won't spend as much time on those. So when it comes to our business class access points, they're all built using the same sort of design philosophy. You can see sort of a breakdown here, and it doesn't matter if we're talking about a $400 access point or we're talking about a $99 access point. They're all going to follow this sort of design philosophy. So what we've done to help sort of increase the longevity of the life of these products is we've tried to address some of the main issues that cause failure in solid state components. So one of the main causes of failure you're going to run across is heat fatigue. So basically heat builds up on the boards. It can cause the little micro switches inside the chips to fail. It can also cause solder joints to fail or weaken over time. So to combat that, our APs have a large metal heat sink that you will find behind the PCBA that's designed to help draw heat off that board. And you will also find we've got a lot of vent holes. And that's to help get that heat dissipated out of the housing to keep things cool inside. If you look at some of our less expensive competitors, they don't even have vent holes to let heat out, let alone a heat sink. Another cause of failure that you've often run into here is electrolytic capacitors. They're little capacitors filled with sort of a cloth-like material and salt water. And they have a tendency to dry up, leak, boil over, etc. So none of our access points use electrolytic capacitors. Everything is going to be based using solid state capacitors. And this is why we can offer a lifetime warranty even on our cheaper business class access points. The other differences you will notice here is on the PCBA. If you open us up and look at our product and look at one of our competitors, is we tend to have a lot more shielding on the PCBA. So generally that shielding is for EMI, electromagnetic interference between the different chips, but our shielding goes above and beyond that and is also designed to help block out 4G and 5G signals. Those signals often are broadcast on chunks of wireless spectrum that neighbor traditional Wi-Fi, and there can be bleed over, which can cause interference, particularly inside larger buildings where you have some sort of a DAS system that's taking the Wi-Fi, or excuse me, the cellular signal from outdoors and redistributing it inside the building. Those devices are often located very close to your access points and can cause interference in those scenarios. Our shielding helps prevent that. Another big difference you will notice is we do not mount our antennas onto the same PCBA as the rest of our chips. Instead, we have a anti-noise spreading sheet that goes between the main PCBA and a second PCBA, which has the antennas mounted on it. So that way there is further isolation between the antennas and any form of EMI that you may get off of the board. So another technology here I want to start talking about here is something that most of our competition doesn't have, and that's dual optimized antennas. So your traditional access point is optimized to be mounted on the ceiling, and it effectively distributes its signal in sort of an umbrella shaped pattern, radiating out and downwards to cover the area below it. Unfortunately, out there in the real world, you often end up in situations where you can't mount the access point on the ceiling and end up having to mount it on a wall. Now, the challenge with that is the antenna pattern isn't optimal for wall mounting. It sends a lot of your signal up into the ceiling, sends a lot of it down into the floor, where it can either be absorbed, depending on the materials, or it can cause interference to access points on those floors above and below you. So our solution to this is we offer on some of our access points our dual optimized antenna technology. And basically what we've done is we've put in two sets of antennas into these access points, one that's optimized for your traditional ceiling mount and one that is optimized for wall mounting. And that way you can choose which antenna set to use based on where you've installed that particular access point. Another technology we have in some of our access points here is smart antenna. So I'm going to talk briefly about that. We go a little bit more in depth into smart antenna in some of the other webinars I do. But one of the main challenges we run into here when it comes to Wi-Fi is called co-channel interference. Basically, when it comes to Wi-Fi, each device takes turns broadcasting. It's very similar to your old school walkie-talkie technology, where if two or more people on your walkie-talkies try to talk at the same time, the signals interfere with each other and you get something that's really hard to make out or understand. Same thing happens with Wi-Fi. So each device generally takes turns to broadcast. There are some exceptions to this with some of the newer technologies like MU-MIMO, which may allow multiple devices to broadcast at the same time. But even then, it's still limited to the number of devices that can be broadcasting at a time. And unfortunately, the wireless spectrum that's available to us, particularly in 2.4 and 5 gigahertz, isn't very broad. So there's a limited number of channels that you can choose from to broadcast on. So you can get interference between different access points in the same building. And there's, of course, also other sources of RF noise. You can get industrial equipment in buildings tends to put out RF noise. And then you've got other wireless technologies that are sharing that 2.4 and 5 gigahertz spectrum. For instance, microwaves use 2.4 to cook food. 2.4 is also used by Bluetooth and other wireless technologies. On the 5 gigahertz side of things, a lot of cordless phones use 5 gigahertz. Some wireless cameras use proprietary 5 gigahertz, and all of that is sort of battling for that space. So smart antenna is one way of solving that. So in addition to dealing with the interference issues, smart antenna also helps increase capacity. It allows you to get more users onto the same access point before they start complaining about connectivity issues. It allows you to put more access points in the same area without them interfering with each other. And it's designed to help increase coverage. So you can get a larger coverage area than you normally would. So this is just showing here, this is your traditional ceiling mount access point with a fixed antenna. And when you introduce a source of noise, in this graphics example here, it's a microwave, but it could be just simply another access point. You get interference that can cause connectivity issues. With the smart antenna technology, rather than having one fixed antenna pattern or two fixed antenna patterns like you get with our dual optimized antennas, you have literally hundreds of different antenna patterns that you can choose from based on where the client device is in relation to the access point. And we have the ability in roughly real time to be able to switch antenna patterns on that. Now, our algorithm that we use not only looks at where the client is in relation to the access point, but it also looks at other sources of RF interference and chooses an antenna pattern that minimizes the ability for other sources of interference to harm or interfere with the signal between the client device and the access point. So here's just a quick example here of a test we did in our auditorium. We compared our access point with an HP Aruba access point. Both of them on the 5 gigahertz radio are 4x4, 6 gigahertz. Similar output powers. We're a little bit more output power than them, but we have smart antenna, they don't. And as you can see here, our speeds are in green, theirs are in blue, and pretty significant performance differences between the TX and RX, between our device and the HP Aruba device, especially on those edge cases where you're talking going through some walls and being very far from the access point to the client. You can see here with the HP Aruba, transmit speed on the client device was 15 megabits per second, where we were able to achieve 474 megabits per second when using the smart antenna technology on our APs. And you see something similar to this on the receive side of things, with the client device connected to our AP being able to achieve a download speed of 453 megabits per second versus Aruba's 70 megabits per second. Now, I know every vendor out there likes to tell you their product is the best. Um, so I'm going to put you here to some third-party stuff here. So a few years back, the University of Brescia in Italy, their computer networking group decided to test the claims made by smart antenna vendors like us and Ruckus and compare them to some non-smart antenna products from Aruba and Cisco. So if you search for Zyxel and smart antenna on Google or the word white paper, we do have a white paper that summarizes their research and what they came up with that you can find on our website. But we've also got here, you can also find their basically the document that documents everything they did in their testing, test methodology, the various tests they ran, the results they got to. So that's out there if you want something that's completely unbiased that looks at smart antenna technology and how it helps things. So just a quick summary here. When it comes to these environments with co-channel interference, which is realistically just about any place that's deploying Wi-Fi these days, up to 70% better performance. Compared specifically to Cisco, up to 56% better performance. And then even comparing one smart antenna vendor against the other, we outperformed Ruckus in these environments by up to 45%. So I do want to talk a little bit here about Wi-Fi 6. It's still a relatively new technology. We'll talk about it here. We'll talk about Wi-Fi 6E a little bit later. But Wi-Fi 6 was the first significant major change to how Wi-Fi works since the late 90s when 802.11 was first ratified. Basically, the way we've been getting faster and better speeds with Wi-Fi ever since then has been by increasing the modulation, increasing the bandwidth that each device uses, and by adding the ability to provide multiple spatial streams. But during that time, very little was done to change some of the main problems that Wi-Fi has. If you sat through my Wi-Fi 101 presentation, I go through a lot of what some of those issues are. But Wi-Fi 6 is the first time really that there's been a major overhaul in the way Wi-Fi works, specifically to address a lot of those issues that have been plaguing Wi-Fi since it existed. So Wi-Fi 6 is in theory faster, being able to provide speeds of almost 10 gigabits per second. Again, this is, if you sit through my Wi-Fi 101 webinar, I go into a little bit more in depth in this, but this is talking about the maximum data that's sent between the client device and AP, which includes a lot of overhead. So actual throughput that you could achieve in one of these types of scenarios is probably going to be, 50 to 60% of that claimed speed, but it's a lot faster than what has come before with 11N and 11AC. It's specifically been designed to be able to handle more clients per AP and to allow you to put more APs into the same space without causing interference. So in many ways, it's trying to solve some of the same issues that smart antenna has been trying to solve, and it does it in a way that's complementary. So if you're looking at Wi-Fi 6 products, if you add smart antenna in there, it just helps improve performance just that much more. One of the key things here with Wi-Fi 6 is that it is dual band. So 11AC, wave 1 and wave 2, actually only improve things on the 5 gigahertz radio. That 2.4 gigahertz radio on your 11AC device is still basically operating using 11N technology. So with Wi-Fi 6, we now have the ability to increase and add these improvements that came with 11AC and now with Wi-Fi 6 onto that 2.4 radio. So big step up for your 2.4 devices, obviously assuming that they do support Wi-Fi 6. And that is one thing to keep in mind here when you're looking at competitors' products. Some of the lower end Ubiquiti products, for instance, only put Wi-Fi 6 technology in the 5 gigahertz radio. They continue to use 11N technology for the 2.4 radio. So something to keep in mind when you're comparison shopping out there. Some of the other technologies that go into making Wi-Fi 6 so much better is the ability to basically carve up the available wireless spectrum into much more flexible chunks. So you can properly allocate the available bandwidth between different devices more appropriately based on what they're able to actually use instead of the fixed chunks that you had with 11AC and older technologies. Some cool technologies here like BSS coloring, which basically allow you to identify on the packets who they're for. So devices that they are not intended for can ignore them, and basically much better utilization of airtime. So one of the challenges you run into when it comes to um, 11AC and older technologies is as you actually add more client devices, the aggregated throughput actually decreases because of basically the lack of scheduling of whose turn it is to talk when it comes to those older Wi-Fi technologies, resulting in situations where client devices are trying to talk at the same time, creating code channel interference, causing packets to be dropped. So you can see here with 11AC, as we increase the number of client devices on the access point, the aggregated throughput goes down. Or with Wi-Fi 6 technology, as you increase the number of devices, aggregated throughput remains roughly flat. And that's true whether we're talking about one access point or two access points. We see that same sort of behavior. Okay, so that's it as far as technology goes today. Now I want to start talking about the different products. So one of the areas where we get the most confusion is with our sort of prosumer line of products, and more specifically, the low-end AX1800 Wi-Fi 6 APs. And the reason for this technology is we've got a lot of different models, and it's not always easy to tell what the differences are. So we'll start here with the 50 series, our lowest end series here. So we have the NWA 50AX and the NWA 55AXE. Primary difference between these two models is one is an indoor AP, one is an outdoor AP. And the outdoor AP has one feature the indoor AP doesn't have, and that's the ability in Nebula to create a point-to-point bridge. So the ability to be able to link, say, two wire networks together over a wireless link, such as maybe connecting an outbuilding to your main building or connecting two office buildings together. So otherwise, they're the same. They're 2x2 Wi-Fi 6 APs capable of speeds of about 1.8 gigabits per second over the wireless network. Now, the one thing you will notice here is there are a bunch of features that are missing that would probably be handy for a lot of business applications. Some of the main ones missing here is there's no captive portal for guest networks. There's no support for MAC authentication or radius authentication of the users. So the next step above this, also an AX1800 AP, is our NWA 90AX series. So the NWA 50 is an Amazon exclusive. The NWA 55 is available to anyone. NWA 90 is available to anyone through distribution. So on the wireless side of things, it's basically the same thing. It's a very similar form factor. Where we start seeing some differences here is this now adds in some of those business features that a lot of your smaller offices and applications would need. So we've got that 802.1x authentication for the users. We have captive portal. We have layer 2 isolation. Now, all three of these APs are 2-year warranty since these are part of our sort of prosumer line of APs. The next AX1800 AP to talk about here is our NWA 110AX. So this is our first true business class access point. So it's going to come with a lifetime warranty. On the Wi-Fi side of things, it's still an AX1800 Wi-Fi 6 AP, but you can see here we've added some new upgrades. So we've added better support for basically the full Wi-Fi 6 feature set. You will notice here that on the 50 and 90, some of the Wi-Fi 6 features are missing. For instance, MU-MIMO only works from AP to client, whereas with the NWA 110, we have MU-MIMO in both directions, from AP to client and from client to AP. Same thing here when it comes to OFDMA. It's available in both directions. And it also adds some additional business class features into the product. And these are features that are basically going to be the same going forward for every access point we talk about today. So that includes things like the use of dynamic pre-shared key, load balancing, the ability to provide NAT on different SSIDs. So you can have a different NAT server running basically based on the SSID the user is connected to, support for SNMP for monitoring, the ability to use our AI to do auto optimization of the wireless network, and support for our optional security services that are hosted on the AP itself. So those are something called Connect and Protect and Connect and Protect Plus. So these provide DNS-based UTM services on a per AP basis. So these are for deployments where your customer's already got a gateway and you either doesn't support UTM features, or it's controlled by a separate entity and you can't add them on there. So it gives you the ability to add security services directly for wireless users at the AP level. And then lastly, the next AX 1800 AP we have here is the WAX 510D, similar here to the NWA 110, but it adds the dual optimized antennas we talked about earlier. It is also part of what's called Nebula Flex Pro. So it comes bundled with a Pro license to Nebula, which unlocks some additional features in the Nebula interface. It also is one of the APs that can be managed by a local area controller. So that's it as far as the AX 1800 products go. Since we had 5 APs here, they're all AX 1800, I wanted to have just a dedicated slide here where we can talk about the differences to hopefully sort of clear up some of the questions that people often have. And now we'll just start going and providing a sort of an overview here of all the different APs we have. So we'll start by talking about our Wi-Fi 5 or 11AC access points that are still currently available for you. We have on the low end side of things, we have the NWA 1123 AC V3. It provides 1.2 gigabits per second wireless using 2x2 11 AC Wave 2. And then a step above that here is our NWA 1123 AC Pro. Now these will be going away this year, but we still do have these in stock. We used to have 2 models, one that came bundled with a PoE injector and one that doesn't. So at the moment, I believe the only thing we have left are the models that don't come with a bundled PoE injector. So it's ideal for those of you that are deploying them on a network with a PoE switch. It's going to power them anyway. So that gives you an upgrade. It gives you 3 spatial streams for 1.75 gigabits per second. It also provides 2 LAN ports on there. One is your uplink port going back to your switch, but it then allows you to run another Ethernet cable directly from the AP to any other type of Ethernet enabled device. So maybe a handy feature there for you so you can run a little bit less cable back to the main switch. So on the Wi-Fi 6 side of things here, we have the NWA 110AX and the NWA 210AX. These are both Wi-Fi 6 APs. They support the full Wi-Fi 6 feature set. Wi-Fi 6 is on both radios. Primary differences between the two is speed. The NWA 110AX supports 2 spatial streams on the 5 gigahertz radio, whereas the 210 doubles the 5 gigahertz speed by supporting 4 spatial streams. In addition, the NWA 210AX, the uplink port is a 2.5 gig multi-gig port. So it has enough bandwidth for that extra wireless speed, so your wired connection doesn't necessarily become the bottleneck for your wireless users. And it also has that pass-through Ethernet port, so you can connect another Ethernet device to it without having to run a cable back to the switch. Going up here now to the 5 and 6 series. So all of these access points that we're talking about from this point forward are going to come with a Nebula Pro license with them. So these will all include 1-year Nebula Pro license bundled with them. And all of these APs from this point onward are going to be able to be managed by one of our local area controllers. For those of you that don't like the cloud and would prefer to use a local controller for your wireless LAN management. So we have our entry-level AP here, the WAC 500. Very similar to the NWA 1123 ACV3, but with that Pro and the controller support in. It also is our lowest priced AP, which supports our secure Wi-Fi feature. So that's a feature that allows you to turn this access point into what is essentially a cloud-managed VPN appliance that can be provided to end users to take home. They plug it into their existing home router, and it creates an SSID that has 802.1x authentication and 2-factor authentication that you can connect to, and essentially creates a VPN tunnel back to the office. So you take your computer home, you need to access some work resources, you simply connect to that special SSID, and you're connected just as if you were in your office instead of at your home. Then the step up from that is the WAC 6103D-I. Again, this is an access point that will be going away probably this year, but we do still have quite a few of these in stock. And this provides 3x3, so faster speeds on the Wi-Fi, and also uses dual optimized antenna. So if you're looking for that dual optimized antenna, this is the cheapest way to do it on one of these 5 or 6 series APs. We also have two different models here of wall plate APs. So these are small APs, generally a little bit less wireless power, that were originally designed for the hospitality and MXU deployments. They were designed so they can mount directly onto a wall plate in the wall with the Ethernet cable coming out of that wall plate and plugging directly into the back of these access points. These access points then have pass-through ports for devices in the room, one of which on each device will provide PoE pass-through. So you can power up, say, an IP phone off one of those connections and then use another connection back to an an IPTV box or module that's plugged into the back of the TV in the hotel room. The main differences between these two is the WAC 5302D-S. It has a smart antenna where the WAC 500 does not. And then the 5302 also has an additional Ethernet port for pass-through, 3 of them versus just 2 on the WAC 500. And it also has a USB port on it. Going up to our Wi-Fi 6 access points in this space here. We've got a number of different models here. We have the WAX 510D, which we talked about earlier on the AX 1800 discussion. We have the next step up from that is the WAX 610D, doubles the 5 gigahertz Wi-Fi speed. Both the 510 and the 610 have dual optimized antennas. And then if you're going up to smart antenna, our entry-level smart antenna AP here is the WAX 630S. So it provides similar features to the WAX 610D, but adds smart antenna to it. And then we've got our flagship Wi-Fi 6 AP, the WAX 650S. It provides 4 spatial streams on both radios, so it gives us both the fastest 5 gigahertz and the fastest 2.4 gigahertz of any of our Wi-Fi 6 APs. It adds a third dedicated radio for using DFS channels, where this third radio monitors additional DFS channels. So if you have to switch from one to another, you can bypass that delay that's normally part of changing channels in the DFS spectrum. It supports a 5 gig multi-gig backhaul, and it has a Bluetooth BLE radio in it for like retail or museum type deployments. And then lastly, on the outdoor side of things, we do still have our WAC 6553D-E. It's an 11 AC with 3 spatial streams. It's a heavy duty outdoor enclosure. It's IP66 or IP67 rated. So really heavy duty. It has a heater built in for extreme cold environments so it can continue to operate. And it uses external antennas that you add to it. And then we have our WAC 6552D-S. Again, this one's one that's going away here pretty soon. And it's a little bit slower. It's 2 spatial streams versus the 3 spatial streams on the 6553, but it does add smart antenna technology. Now, I should add here, this is a directional access point, and the idea here is to allow you to create point-to-point links without having to have that very specific aiming that you generally have to do on outdoor point-to-point links. With the smart antenna, you just have to point it in roughly the right direction, and it will be able to provide and create that link for you. It can provide coverage of up to 90 degrees. So if you want to, you can put 4 of these on a pole for a full 360-degree coverage. And they were designed specifically to be able to support this. So you don't have to worry about interference from each of the APs, even though you've got 4 mounted really close together on the same pole, something which can cause issues in other APs, even when using very directional antennas. For those of you that need some lightweight outdoor use, we offer our outdoor enclosure here. It fits most of our access points and provides basically a waterproof enclosure with venting. So you can mount most of our APs in an outdoor environment where it doesn't require the extreme protection that the 6553 and 6552 provide. We also do have, and I forgot to add the slide in here, we do now have a Wi-Fi 6 outdoor AP, same form factor of the 6553. It is the WAX655E, and that's a Wi-Fi 6 outdoor basically version of this guy here. So that's it for our Wi-Fi 6 and 11 AC APs. I now want to talk briefly about Wi-Fi 6E. So Wi-Fi 6E is something that became available mid last year. So 6E has to do with the fact that Wi-Fi 6 was designed to be able to work in any chunk of spectrum. And the US FCC opened up this 6 gigahertz spectrum, which previously required that you had a license to be able to use it, and have opened it up for unlicensed use here in North America, and some other countries have followed as well. So this 6 gigahertz spectrum provides basically double the capacity of 2.4 and 5 gigahertz for you. Now, one of the problems that we run into with Wi-Fi 6 is in order to take advantage of all the benefits of Wi-Fi 6, you can't have any legacy devices on there. When you have a legacy 11AC or 11G or 11N device, the AP basically goes into sort of a compatibility mode, which reduces the performance for those Wi-Fi 6 devices. So with Wi-Fi 6E, there are no legacy devices. There are only going to be devices purpose-built to use this new Wi-Fi 6E on the 6 gigahertz spectrum. So you won't have some of those drawbacks. So you will be able to maximize um, performance on that 6 gigahertz band. Um, because of this extra spectrum, you now have you now have 7 non-overlapping 160 megahertz channels for maximum performance, whereas in the 5 gigahertz spectrum, you've only got 2 available. So as soon as you add a third access point in there, you're going to have interference or going to need to only use 80 megahertz channels to open up stuff. And there's no interference because there's, for the most part, no other legacy devices using 6 gigahertz. So just to give you an idea here, here's the size of the 2.4. Here's the size of 5 gigahertz. And as you can see, 2.4 and 5 gigahertz combined have less spectrum available than 6 gigahertz. So 6 gigahertz is going to be really great for those high density deployments where you've got a lot of different devices there, whether it's a lot of access points or a lot of users, because it's going to minimize some of the interference. It's also good for any sort of emerging technology that needs a lot of bandwidth. Now, the negatives to Wi-Fi 6E, the two main ones for you are going to be the range is not as good on the 6 gigahertz channel than on the 5 gigahertz. That just has to do um, with basically as frequency goes up, the ability for radio frequencies to travel through things becomes less. That's why, an AM radio station, the signal goes a lot farther than an FM radio station. It's the same thing here. So that's why 5 gigahertz had less coverage than 2.4. And now 6 gigahertz has even less coverage than 5 gigahertz. So you may need to use more and access points to cover the same area that you would now using just 2.4 and 5. The other challenge is that 6E currently is only legally allowed to be used indoors. The FCC last year was supposed to come out with rules and guidelines for using 6 gigahertz outdoors. The problem is those legacy users who were using it when it required a license are still using it, and they have sued the FCC um, to prevent them from allowing people to use it outdoors. So while those lawsuits go on, Wi-Fi 6E is going to be an indoor-only technology. So now we've talked about the technology. Let's talk about the models. We have 3 different models of access point that use Wi-Fi 6E. The first 2 we're talking about here have a technology in them that we're calling band flex. Basically, there are 2 radios in this access point, one that's dedicated to 2.4 gigahertz and one that can operate either in 5 gigahertz or 6 gigahertz. So if you're just looking to add 6 gigahertz to your existing network, this might be something for you. Or if you realize that very few of your users today are supporting Wi-Fi 6E, but maybe in the near future, a lot more will, you can deploy these APs today, providing service on 5 gigahertz. And once we've hit that threshold where there's finally enough users out there using that have devices that support 6 gigahertz, you can flip it over to use 6E instead. So the first device here is one of our lightweight APs here. It's an NWA 220AX-6E. It provides speeds up to 5.4 gigabits um, combined between the two different radios here. It supports Nebula Flex, so it can be managed either in the cloud or standalone. Supports the full Wi-Fi 6 feature set. Then the step up from that is the WAX620D-6E. This adds Nebula Flex Pro support. So that means it comes bundled with that 1-year Nebula Pro license or can be managed through a local area controller. And then this one also adds in there for us a dual optimized antennas for that flexibility between ceiling and wall mount. And then our flagship 6E product at the moment is the WAX640S-6E. So this is a tri-radio access point. So you've got 3 radios, one for 2.4, one dedicated to 5, one dedicated to 6. So all 3, so you can support users on all 3 bands simultaneously. The 6 gigahertz radio supports 4 spatial streams. The other 2 radios are each 2 spatial streams apiece. This has our smart antenna technology in it. And this is a Nebula Flex Pro product. So again, comes bundled with that 1-year Pro license or can be used by one of our local controllers. So that's it as far as our business class APs go. I do want to talk briefly here about, just doing some comparisons between us and some of our competition. So we'll start here on the low end 11AC, the NWA 11AC, 1123 AC Pro. Probably its main competition in this space is Ubiquity's UAP AC Pro. So let's take a look at what some of the differences are here between them. Both are 3x3, so 3 spatial streams on both radios. You will see here we have significantly more output power, 27 dBm per radio versus 22 dBm per radio on the Ubiquity. So more power means that signal can go further. It means better signal to noise ratio. We offer that dual optimized antenna where theirs is just this single standard antenna pattern on theirs. Higher gain antennas versus what's built in onto the Ubiquity. Full support for SNMP V2C and V3, something that's missing on the Ubiquity. And probably the most important thing here for us, lifetime warranty versus 1-year warranty if you buy it through distribution, 2-year warranty if you buy it direct from Ubiquity at full retail. Next step up here, we'll go to one of our Wi-Fi 6 APs, the WAX510D. So this competes with like the Aruba 505. And then Ingenius's EWS357 and ECW220. So basically Ingenius has 2 different APs, same hardware essentially. One is for the cloud, one is not. So very similar here. Some of the main differences here is while Zyxel and Aruba are the full Wi-Fi 6 feature set, the Ingenius is using an older, what I'm going to call a pre-Wi-Fi 6 chipset, which is missing a number of the features that are required for full Wi-Fi 6 functionality to take advantage of it. Unfortunately, in the space here, there's nobody enforcing what is and is not Wi-Fi 6. The Wi-Fi Alliance does do some testing and certification, but it's not required to be able to go through that to use the term Wi-Fi 6. So what happened here is instead of people calling devices, pre-N or pre-Wi-Fi 6 in this case, or following the 11AC route where you had wave 1 and wave 2, a lot of vendors call everything Wi-Fi 6 regardless of the features that are supported. So that's what's going on here with Ingenius. So if you want that full Wi-Fi 6 feature set, you need us, or in this case, Aruba. You'll see here, just like with the Ubiquity, we've got much more powerful radios in our access point versus our competition. Otherwise, very similar here as far as the features go. So true Wi-Fi 6, dual optimized antenna versus static antenna, more powerful radio, and generally a lower price. And then up on the high end here, we'll use our WAX650S. So again, we're comparing to Cisco, Aruba, Ruckus R750. So if you want smart antenna, only us and Ruckus offer the smart antenna. We've got higher output power than Ruckus does on that 2.4 gigahertz radio, same output power on the 5 gigahertz radio. Both of us are higher end than any of the Cisco or Aruba products on there. Only us and the Meraki MR45 have that dedicated monitoring radio in them. So that's something that's missing from the Ruckus. We provide 5 gig uplink port, where most of our competition here is only 2.5 gigs. And to fully take advantage of that 4 spatial streams, you really do need more than a 2.5 gig Ethernet connection. We have that pass-through port on ours, where some of our competition here on the Cisco side does not. So those are the differences we're talking about here. And with that, guys, that ends today's webinar. I appreciate you coming out. So most of our webinars that we do, whether it's me, whether it's Marcus, whether it's Tri, are recorded, and we do upload those to our YouTube channel. Since Zyxel is a huge global company, each region has their own channels. So here for us, for our webinars, you will find those at youtube.com/Zyxel America channel. And we also have case studies there. We have how-to videos there. So something to check out, see maybe some of our past webinars you've missed that you might want to see. You can find them on there. And then, of course, you can always connect to us at LinkedIn at Zyxel US channel. With that, if you have any questions, I will happily answer them. Again, use the question and answer interface in Zoom to send me those questions. While I wait to see if any questions come in, I do also want to point you to our web forum. Simple URL, forum.zyxel.com. So this is what I would call your sort of traditional user forum for Zyxel users and installers to be able to discuss things with each other. Unlike some of our competition, these forums are monitored by our product management and R&D teams. So, if we see, someone has a suggestion for a feature change or an implementation change, and a bunch of people join on and say, yeah, it's a good idea, that will certainly increase the chances that we'll roll that out sooner rather than later into the software. Our forums are also where security alerts are first published, where release notes are first published. So it's a good idea just to keep on, browse that from time to time to see what's been going on. Okay, so Paul has a question here, and it's a good question. It's, I was talking about the Bluetooth radios that you can find in the WAX 650S, for instance. It can also be added to the WAC 5302D-SV2 via Bluetooth dongle. So the question is, what is that Bluetooth for? So when you're looking at products, we use it for Bluetooth low energy, BLE. And basically it allows the access point to send out beacons that can be detected by phone's Bluetooth feature, particularly Apple products. So you can create some sort of app interaction. So when they get close to a certain part of the store, the app behaves in a certain way. We have done implementations at museums where you have one of those self-guided audio tours, and that's how the audio tours work. It's how they'll know that you are near a certain exhibit and will be able to tell you about that exhibit just based on those Bluetooth beacons. With some of our competitors' products, they will have Bluetooth, not for Bluetooth low energy, but just for configuration. So if you're doing the initial configuration of the AP, you can connect to the AP over Bluetooth to do that initial configuration. And then after that, you don't use the Bluetooth for anything. So again, we don't use Bluetooth for that, except I think on some of our LTE products, but not on our APs. Our APs, if they have Bluetooth, it's going to be for that Bluetooth low energy application. Jeff is asking a question, are these immune to the security flaws from 2022? So I don't know which specific security flaws you are referencing there, but this would be a place where you could go to the forum. Again, that's where our security alerts are. So anytime we've got any sort of security flaw, whether it's something specific to our devices or it's taking advantage of a flaw in the Wi-Fi standard, that's where we will generally post updates. So usually when a new security flaw comes out, we will post something about what that flaw is. We will reference the security case number, what is it called, CVE number, so you can look into it to get more details. And we will let you know whether there's a patch available to solve it. And if there's not a patch, when that patch will come available, or whether it will be patched in a full release firmware, or if there is no patch and it's just something where you have to change your best practices to work around it. So we've got a question here. What is the life cycle for higher end units? So when it comes to the life cycle of our products, so like I said, all of our business class APs have a lifetime warranty. So the way the lifetime warranty works is basically we warrant the device um, for manufacturing defects for the life of the product, and the life of the product is defined as basically 5 years after we discontinue the product. So whatever warranties on there is good until we discontinue the product, and then it's good for another 5 years after that. So the question is, well, how often do we discontinue the products? And in general, I would say Zyxel is one that we tend to be long in the tooth. A lot of our competition is constantly rolling out revisions, such and such Rev 1, such and such Rev 1.2, such and such Rev 3. We generally don't do that. We tend to roll out one version. And even if there's maybe some minor changes in the components, keep it going for much longer than most of our competition does. There's no dedicated rule of thumb. The WAC 6553, I mean, they've been around for what, 8, 9 years, I think. So we tend to keep things longer. It just depends on the technology. We just started phasing out most of our, 11 AC products last year, and we've still got some of them still available. Some of them, like the 1123 ACV3, there's no plans to discontinue them anytime soon. It just depends on, component availability and demand. Generally, we don't discontinue products until the chipset vendor discontinues the chip that goes into them. That's generally why we sometimes get some very short announcements that products are being discontinued, is because we only find out when the chipset vendor cancels our orders and says, hey, we've decided to stop producing these older chips. So generally the products are around for a long time, as long as the chips are still available and as long as people are still buying them. I hope that answers the question. I don't have any, hard rules of thumb for how long certain models will be sticking around. Okay, I don't have any more questions in the queue, so I'm going to go ahead and end today's webinar. We do webinars on Tuesdays and Thursdays. Thursday webinars are generally like today, sort of higher end overview type presentations. Tuesday presentations tend to be more of the, here's how you configure a device to do X, here's best practices for doing Y type of presentations. And again, they all get most of them get recorded and uploaded to our YouTube page. So you can always go back and watch a previous version of it there. So thank you, everybody. Hope to see you at one of our upcoming webinars.